Okay, so hello, good day everyone. Welcome back to my channel. For today's video, we'll talk about the exponential function formula of integration. Okay, so before we begin, let me just explain to you how we arrive at this formula. Okay, suppose we are differentiating an exponential function. Say for example, we have a raised to u. Yan. So it should be noted that your a here is constant and your exponent contains the independent variable. Okay, so if we evaluate the differential of a raised to u, the formula, it says here, this is equal to a raised to u ln a differential of u. Yan. So this is the formula for the differential of a raised to u. So another one, how about if the base is a natural number? Say for example, we have the differential of e raised to u. Yeah, so natural number yung base. So this will be equal to, you can use the same formula. This will be equal to e raised to u ln e differential of u. Yan. But since ln e is equal to 1, so this can be simplified as e raised to u du. Yeah, so therefore, your differential of e raised to u is actually equal to e raised to u du. Yan. So, dalawa yung formula natin for differential of exponential function. You have here the differential of a raised to u. Okay, so your a here, take note, your a is constant other than e. Okay, because if their base is a natural number e, then this will be your formula. So that is the formula for differential. Now, applying the principle of integration, di ba? Integration daw is just the inverse operation of the differentiation. So out of these formulas, we can actually derive the formula for integration, the exponential function formula for integration. Okay, so first this one muna. Okay, so if we integrate, if we get the integral of a raised to u ln a du, so this is actually equal to a raised to u, right? Okay, but since ln a, your ln a here, this one, ln a is constant. So you can put it outside of the integral, diba? So this will be equal to ln a integral of a raised to u du. And this is still equal to a raised to u. Yan. And dividing both sides of the equation by ln a, so you will end up with the integral of a raised to u du, and this is equal to a raised to u over ln a. Yan. So this is now your formula for the exponential function formula for integration. Yan. Of course, you have to put here plus c. Don't forget the plus c. Yan. So this is now the formula, the exponential function formula for integration. Okay. Another one is if the base, instead of a, the base is a natural number e. So how do we derive that, the formula, the exponential power formula for integration, if the base is e? Of course, it will be based on this on this equation also. Okay, so if you integrate e raised to u du, this will be equal to e raised to u. Yan. Of course, don't forget plus c. Yan. So this is now the formula. Yan. Okay, so itong dalawa na to, this is our formula for the exponential function formula for integration. Take note ha, you have the integral of a raised to u du, and that is equal to a raised to u over ln a plus c. And of course, the integral of e raised to u du is equal to e raised to u plus c. And so you have to memorize this formula. Okay, let's have an example. I have here 3 examples. Okay, the first example I have here, the integral of e raised to 4x plus 1 dx. Yan. Okay, so obviously, your base is natural number e, and your exponent contains the variable, the independent variable x, okay? And so we will use the exponential function formula of integration. Okay, so you have to identify your u because it says here e raised to u. So you have to identify your u, and that is equal to 4x plus 1, diba? And of course, your du is equal to, this will be 4 dx. Yan. Then, the next step is you will apply the left side of the formula. You have to apply the left side of the exponential function formula. And this will be equal to the integral of course, your e raised to u, and your u is 4x plus 1 du, and your du here is 4 dx. Now, obviously, we have 4 here, so you have to introduce a correction factor, which is 1/4. Yan. So that this quantity here is still equal to the original given function. Okay, so after this, you have to copy 1/4. Then you have to apply now the right side of the exponential function formula. And that is e raised to u plus c. So this will be e multiplied by e. Your u is 4x plus 1. 4x plus 1. Yan. Of course, don't forget your plus c. Yan. So, simplifying this further, this will be e raised to 4x plus 1 all over 4 plus c. Yan. So this will be your final answer. And of course, we have to check. Okay, to check, we just need to differentiate our answer. And if we arrive at the same function, then our answer is correct. Okay, so to check, we just need to differentiate our answer. Our answer is e raised to 4x plus 1. 4x plus 1 all over 4. Of course, your plus c. Yan. So this will be equal to, I can put 1/4 outside of the differential because 1/4 is constant. So this will be 1/4 differential of e raised to 4x plus 1. Yan. Differential of c is 0, so I will not put it there na. Okay, simplifying this further, 1/4 differential of e raised to 4x plus 1 is equal to e raised to 4x plus 1. Yan. Differential of 4x plus 1. So this will be 1/4 e raised to 4x plus 1. Differential of 4x plus 1 is 4 differential of x. Yan. So your 1/4 and 4 will cancel out. And yung matitira na lang is e raised to 4x plus 1 dx. Now, as you can see, this quantity here is exactly the same with the original given function. Diba? Okay, so therefore, our answer, this one, is indeed correct. Okay. Okay, let's have another example. Okay, so another example number 2, I have here the integral of 2 dx all over 3 raised to x. Now, obviously, you cannot use the power formula here because the exponent contains the independent variable. The only formula that you can use here is the exponential function formula. Okay, so but before we use the exponential function formula, let us first manipulate this function so that you can see we can use the exponential function formula. Okay, so if you manipulate this one, this could be equal to, your 2 is constant. You can put it outside of the integral sign. So this will be 2 integral of dx over 3 raised to x, right? And 3 raised to x, you can put it this way. So this will be equal to 2 the integral of 3 raised to negative x dx. Yan. Okay, now, in this form, it's obvious that you can use the exponential power formula. Now, you can take note, you can only use the exponential function formula if your exponent contains the independent variable. Okay, so we will use the exponential function formula, and you have to identify your value for u, and your u here is obviously that is negative x, and of course your du is your negative dx. Yan. Then after that, we will apply the left side of the exponential function formula. Now take note that your base here is 3. It's not a natural number. So what we will use here is this formula. Yung unang formula. This one. Your integral of a raised to u du is equal to a raised to u all over ln a. Take note, meron pang over ln a. Of course, your plus c. Okay, so we already have identified your value for u and your du. It's here. So the next step is we'll apply the left side of the exponential function formula, and this will be 2 integral of a, your 3, raised to your u is negative x, and of course you have your the negative dx, your du. And because of this negative sign here, this quantity is not exactly the same with the previous one. So you have to manipulate again. So you have to introduce correction factor -1. Or you have to multiply this by negative. So this will be -2. So this is equal to -2. Now we will apply the right side of the exponential function formula. And that is a raised to u over ln a. Okay, so your a here is 3 and your u is negative x all over ln a. And your a is 3. Yan. Yan. So this is your answer. Of course, your plus c pa. Okay, but we need to simplify further. So this is equal to -2. I can put 3 raised to negative x in the denominator. So this will be -2 all over 3 raised to x. Paging positive na siya, yung x, and multiply by ln 3. Yan. Of course, plus c. Now this will be our final answer for the integral of 2 dx all over 3 raised to x. Yan. So this is our answer. Of course, we have to check. Okay? Let us check lang muna. Okay. So if we check, of course, we just need to differentiate our answer. And that is -2 all over 3 raised to x ln 3 plus c. Yan. Okay, so this will be equal to, let me put -2 over ln 3. -2 and ln 3 are constant, so I can put it outside of the differential. So this will be -2 all over ln 3. And you'll be left with the differential of 1 over 3 raised to x. Yeah, differential of c is 0. Okay, so this will be equal to, we'll just copy these constants, ln 3. Differential of 3 raised to 1 over 3 raised to x, or you can put it as differential of 3 raised to negative x. Yan. So this is equal to, copy lang, 2 ln 3. The differential of 3 raised to negative x is, this will be 3 raised to negative x ln 3 differential of negative x, which is ano ba yung differential ng negative x? Negative dx. Yeah, negative dx. So your negative, this negative here and this negative here will cancel out, and your ln 3 and your ln 3 will cancel out also, and you'll be left with this is equal to 2 multiplied by 3 raised to negative x, and of course your dx. Yan. And arranging this this quantity, this will be 2 dx all over 3 raised to positive x. Yan. So this is our value if we integrate our answer. 2 dx all over 3 raised to x. And obviously, that is equal to the original given function. 2 dx all over 3 raised to x. Yan. So therefore, this answer right here is indeed correct. Yan. Okay, so that's how we check Okay, I have here one last example before I end this video. Um, so I have here an example. We have here the integral of sine 2 theta e raised to cosine 2 theta d theta. Yan. So your independent variable is theta. And since your exponent of the natural number e is it contains the independent variable theta, so therefore we can use the exponential function formula of integration. And so we'll use that EF. And of course, you have to identify your u first, and your u is cosine 2 theta. And if you get the differential of cosine 2 theta, this is equal to negative sine 2 theta. Differential of 2 theta is 2d theta. Yan. So this is equal to 2, negative 2 sine 2 theta d theta. Yan. So this is your u. Now, if you apply the left side of the exponential function formula, so this will be the integral of e raised to u. Your u is cosine 2 theta, cosine 2 theta multiplied by du, and your du is negative 2 sine 2 theta d theta. Okay, now if you compare this quantity, if you compare this quantity with the original given function, obviously they are not equal because of this negative 2. Diba? Okay, so you have to introduce a correction factor, and the correction factor is negative 1 half. Yan. So negative 1 half yung correction factor natin. Now, after introducing the correction factor, we'll then proceed with applying the right side of the exponential function formula of integration. Okay, so this will be 1 half, negative 1 half, e raised to u, and that is cosine 2 theta. Of course, don't forget your plus c. Yan. This is now your answer. Yan. So this is our answer. This is our final answer. Okay, now let us check. Check natin. So we have to differentiate. We'll differentiate our answer. Differential of, what's the answer? Negative 1 half a raised to cosine 2 theta. So we have here negative 1 half e raised to cosine 2 theta plus c. Yan. So we have to differentiate this quantity. So this will be equal to negative 1 half differential of e raised to cosine 2 theta. Yan. Copy your negative 1 half. Differential of e raised to cosine 2 theta is e raised to cosine 2 theta. Differential of cosine 2 theta. Cosine 2 theta. Yan. So this is copy lang. This is 1 half a raised to cosine 2 theta. And your differential of cosine 2 theta is, of course, this is negative sine 2 theta. Differential of 2 theta is 2d theta. Yan. So, simplifying this further, your 1 half and your 2 right here will cancel out. And your negative also, this one and this one. And ang matitira na lang is, let me put it here, e raised to cosine 2 theta. Of course, the sine 2 theta d theta. Yan. I'll just arrange this. I will write sine 2 theta first. E raised to cosine 2 theta d theta. Yan. Now, obviously, this result is exactly the same with the original given function. Yan. Integral of sine 2 theta e raised to cosine 2 theta d theta. It's exactly equal with this one. Okay, so therefore, this answer right here is indeed correct. Okay, so that's how we solve integral function involving exponential function. Okay, so before I end the video, let me put it on screen again. The formula for the exponential function formula of integration. It's right here. Okay, so the integral of a raised to u du is equal to a raised to u all over ln a plus c. And the integral of e raised to u du naman is equal to e raised to u plus c. And so please memorize this formula. And I will give you your practice exercise 1.5 later. Thank you and God bless.